Hello and welcome to another Blender live noding video recording. Um, we're gonna be using animation nodes again today, and the topic we'll be covering will be color and lines. It's pretty basic topic. However, it's interesting, and it's something that many people got confused at first when they first starting to learn coding, or probably um, using node-based procedural workflow. Color is fun because you can see it on on your screen right away. It's kind of a quick way to interactively see the result. And yeah, let's just get into it. We have the default layout as usual. Let's switch into the compositing. We probably don't need this part for now. I'll hide it, and let's get started. Let's create a new node 3. Let's hide the light and the camera. We have our default cube. We can delete it for now. Okay, let's get started. So we're gonna need to create some lines, which will later on the lines should be, we will somehow turn the line so that we can render it in Blender, and then we will deal with the material and the coloring, similar to last time, except that this time we will cover color in more detail. So let's just get started. You will see me making mistakes as well, because it's a live noding and I don't really have any planning or anything. I'll just right away start recording. Okay, line. So in animation nodes at the moment, we actually have only two generators, the line and grid. There should be circle as well at some point, and some other mesh, but they're a good starter because eventually maybe we have like a thousand nodes we can use, but by then it will be a lot more complex. For now, we simply have lines and grid, and we can use line for what we are trying to do now. Okay, let's create a line. Mesh generators line. And let's have a look. I will right away turn the line into a spline, because in Blender um, you can render lines if you use like things like skin modifier. However, I will be using spline because spline have a little bit more control over the surface. Okay, spline. I'm just gonna shift A, and under the spline we have spline create from edges. Yeah, that's exactly what we need. We have the vertices, we have the edge indices, and the spline needs to be outputted as an object. So we plug that in, make sure this is on, and at this moment we don't really have any object, so we're gonna create a target for it. Click on it, and we have our lines. We're gonna give it a bevel, so it's become like kind of like a cylinder, like a pipe. You can increase the resolution as well if you like, but for now we don't really care. We just leave it at 0. I'd like to work today from the top camera looking down, so I want so that the lines need, instead of pointing up in the Z directions, I want it to be I want the line to direction to aim at the x-axis, so I will just put the 10 in there. 0 steps will be how many vertices you like for the line, so we can leave it at 2. So with the view, we can go to the top view. Now we have our beautiful lines. Okay, let's save it as line, color, animation nodes, and now the next thing I want to do is to create instance of lines. Let's see, should we, okay, maybe we should color the lines first, and today I will be just using Blender render, so I will give it color from the object color attributes. So, and in order to be able to see it, as you know, we need to create a material, and underneath the material we turn on the object color. So that's what we need. Next, we will want to create like a copy. We don't know how many copies, but it's gonna be procedural. So we're gonna need a object instancer, and then whoops, spline goes into spline. The instance will be it needs to be a curve, so it's curve 3D. Let's say 5 for now. So we have our curve, this thing, and so we have our target, and for this I'll just tap W, and we're gonna loop through objects. Sorry about the background noise, the neighbor is having a party today. Yeah. We have our 5 objects goes into the loop, and for each these 5 curves that we cannot see yet, we will pass on this data. Let's give it a go. Object goes into the target, and then we probably already have 5 objects there. We just need to object transform, and location, pass in the objects. The location needs to be we need kind of like list, or we're gonna use the index value, combine vector, plug that in. So it needs to go up, so in the Y directions, boom. So we have 5 different lines. We might want to increase the resolution. We can delete the previous line because it's actually the previous target objects. And then we will copy the material. Control L, make links to the material. Okay, it's showing as a half cylinder, which is pretty interesting. Is we want to turn it into a full pipe. So in here we turn on the fill mode and then change it into full. Alright. This guy over here, object color, here it's white color, but we will use animation nodes to colorize this pipe. In fact, we will do it right away. I'm gonna save first and save another version. So color, random color, that's always the first thing I use to test what I'm doing. Random vector, and for the color itself we will use the attribute output node, and the object's gonna be our pipes. The parameter or the attribute is gonna be color, because it's just a object color, and it's complaining now. It says value has a wrong type, so I need to pipe in like a color. If you choose color, this might work. Okay, that's working, and I believe we have control over the alpha as well, and we can see it if we are in the texture or material, but we might need light, so create light. Hemisphere is good. Alpha, yep, it's working. We can delete this guy. The value here is actually 4 instead of like a vector. Vector has 3 floating values. We actually have 4 different values coming out from things like color node. Let's check it out. If we debug and look at the output, you see we have the RGB, red, green, and blue value, and as well the alpha or transparency value, which is 1 at the moment. So in order to create our own color, we will need to create a list of 4 colors as well. So it's going to be a number, it's going to be a float, but it's a 4 floating number like that. The last number is going to be 1. It's going to be the alpha. Let's try pipe it in. Yep, it seems to be working. So if we have like 1, 0, 0, we have a red color because it's RGBA, and if you have the value goes from 0 to 1, 0 the lowest, 1 maximum, and the value in between we can adjust. You can actually have value that goes over 1, that really bright red, but we might do that. Yeah, so now we have a working colorful lines. RGB, let's see, 1. If it's all the RGB value is 1, you get white, and if all the RGB 0, you get black, and whatever in between is a gray value. So give it a try. We can actually increase the value as well. I mean, increase the number of lines, because everything is procedural now. Let's say if we increase it to 10, we have 10 different lines, but as you can see, they have like the default material, which is none. They need to be using the same material, so this is probably one thing that I will have to request from animation nodes developers, so that they have a way to connect the materials directly into the object instance right there. For now, we're gonna do it like this. Okay, what are we going to do next? Randomize. Yeah, we need to randomize the color. So let's try to randomize the RGB. We're gonna use a random number node, and it has a min and max, and it will output the value based a random value between 0 and 1 at the moment. Is so it's gonna do that. Let's plug in the color. If we use the same value for all RGB, that's what we're gonna get. It's grayscale. It's a random grayscale value, and we can play with the node seed, and we can see it's all just a random grayscale value. That's the thing I like about animation nodes or procedural workflow like this, because you can see the output right away. It's very interactive, and you can play it with alpha, of course. If you want something that's more random for each RGB, you need to have a random number with a different node seed number. The seed, okay, the seed is different. I'll plug in the index into the seed. There. Cool, we have everything's working. It's a random color, random values for RGB, so we have random color like that. So it's pretty basic, and you might see this in all in other 3D program. Maybe even if you use a program like let's say Houdini, or maybe using like a processing and typing code to generate numbers for colors, you will be dealing with this RGB and random color like this. So with the color, with RGB, sometimes it's really hard to work out the color. Sometimes I rather use something called HSV, or sometimes it's called HSB, which stands for hue saturation value or hue saturation brightness. And in order to do that in animation nodes, at the moment you need to use a Python script, because we don't have node that deals with RGB and HV. That's probably the next node in my wish list for animation node, but that's okay because we have the script node. Script node always come in handy, because with script node you have access to Python, and with Python you have access to hundreds or maybe thousands of modules that people already created, and you can just simply get the right code and transfer it, so that you have like an input and output, and you have like a system already working. Okay, but for now we're just gonna make something simple. It's HSB to RGB script, and let's create a new text for the script. Turn on the numbering, the line numbering, and the syntax highlighting. Alright, so we need Python script to convert HSB value into RGB. Okay, we can use a module called Color RGB. I know it because why I Googled it before, and there's this question asked by user at Blender Stack Exchange: how to send HSV value to color picker in Blender from Python console. We can only send RGB, so Blender obviously is using RGB, but then we sometimes work easier using HSV. So from math we can use math utils module, which is Blender specific, or we can use Python standard color RGB module, and we can copy paste this part, paste it. Okay, my copy paste doesn't work. Let's try again. Copy, paste. Okay, nice. Import color sheets. Color sheets HSV to RGB. So we need to put our input will be in HSV. HSV. So our input variable name will be, it's gonna be in float data type, not list, float. So it's gonna be HSV. The output is gonna be vector. So, yeah, I think it's gonna be vector. It's a 3 value, and it's gonna be the RGB color. So RGB color will be the output. It will be a vector, a list of 3 numbers, and that's it. So we will have this working for us. HSV to RGB, and so with our setup right at the moment, let's save it. We have 1, 2, 3, 4 values. So this node will create a 4 value for us, 4 floating value. Sometimes they write it like this, float 4 or something. So we need to break our thingy, break our vector into 3 values, X, Y, and Z, like that. Let's do it really slowly, tidy up the node so it's clearer. HSV will work if, okay, the value, we have the value working, nice. Saturation, let's make it 1, and then so we have the H, which is the hue. It will goes from red to yellow, orange, green, blue, purple, back to red, and keep going and going and on and on. It's like a spectrum of rainbow color. If we, it should be like 1, 0, and let's say I have the hue at 1. We can play with the saturation. You have something that's more faded and pale, and then you can play with the brightness as well. So it's pretty straightforward, and normally HSV will quickly give you a color that's more eye-pleasing. Later on, you might, when you work with color, you might already have your own palette, color combination of 3 or 4 or 5, and you can get a combination from, I think from Adobe Color, have like a collection of swatches. Is my internet working? Color, Adobe Color, and there is a Python that takes color from Color, and from here you might be able to use the script inside Blender, so Blender will take the color and use it for whatever you're trying to do. So with the color, so we don't need this random number. Oh, maybe we can use the random number. Let's use random number for the hue. So cool, we have this totally random color. And maybe you need a if you want a random rainbow color, not a random, I mean just a rainbow color from red, orange, yellow, and so on, you can use a color remap or something. It's a map value, map range. So why do I use map range? You will see, because we have index, right? The index, the value of index start from 0 until the total number of your copy. The total number of copy will be under iterations. You can plug that in because we want the final value to be between the range of 0 and 1. So you can plug that into the hue, and you have rainbow color. So no matter how many lines you have, you will have a rainbow color. It's really handy. You can, let's say we are randomizing the saturation as well. We play with the min and max. Yeah, that's cool. And the value, you can have random value. So it's quite sophisticated system, right? If you so you have this thing going, since we have our lines inside the loop, so that's really handy. What's gonna happen is we can change the line, the length of the line for each copy, so that's really handy. You can have the line outside of the loop, so it's gonna be faster, but since the line itself is inside the loop, you can play around with all this number. You can even maybe create like a lines that's more like array. Should I try that? Maybe later. The end is 1, so maybe the end. So just like what we did with the color, I will use a map range. Map range. So the index goes into the value, iterations, the max total number will goes into the max, and then we have map range. Let's see. I made a mistake, but we will see. So we need a 3 value there because vector, combine vector. Plug that in. No, didn't work. Try again slowly. Okay, works. X. So we have the X value that we can play around. Map range. We can use map range. Yeah, let's try map range. So that's a cool effect. You can have the smallest lines. Yeah, cool. In fact, you can have like a functions, like a math function that goes in there as well, and you can even have like a negative number like that. If you have a sine wave, it will give you like a sine wave. For now, we're just gonna give it random value. So random value, again, random number. plugging the index, random number goes to X, random number between 0, no, we don't want 0, maybe something like that, random number between 1 and 10. And so we have lines with random number, lines with random length, and lines with random color as well. So line and color, my favorite subjects. But you can change the lines into anything else, any like maybe a grid or 2D or 3D grid, and you have like a beautiful you can easily create a, what is it, HSV RGB 3D cube, something like this. Yeah, something like this you can easily create from this setup. Map range, object transform, and let's say with the lines, if we want to if you like scrub the seed, you get something like this, right? Seems like doesn't have like any kind of pattern, but you can use this, you can add a value into the seed, and you have something that's more like a kind of like a wave, but super random wave. Okay, let's see, we have our value, currently it's like a rainbow. It's still like a rainbow color, so we actually want it to be random. So select this, create our, oh, sometimes you like this as well, this kind of effect. I like that a lot. Kind of red but with a slightly random value. It feels more natural. And let's see, lines and hue and random color, random. It's gonna be, that's what BlenderSushi is all about. It's gonna be random, live noding, random explorations. Feel free to ask questions in the comments. By the way, if you look at this video and then you have some ideas or questions, just ask in this channel. I actually made a BlenderSushi Facebook page just earlier today, so you might want to subscribe over there or in this YouTube channel. Let's see, our lines is working, cool. Can we actually wiggle the line? Wiggle. Let's give it a try. Do we have wiggle number? Wiggle. Vector wiggle. Euler. Number wiggle. Number wiggle. Let's see what number wiggle do. Index. Seed. Index goes into the seed. Number goes into X. We have super small wiggle value. We can evolve the wiggle. As you can see, the wiggle actually, the value of wiggle goes in minimum and maximum. It goes into negative and positive. We can easily remap it. Map range. So, boom. It's cool. Get rid of the number. You can leave a random number there. Let's save this. Evolution, amplitude. Okay. No, actually I lied. Actually, it didn't go too high. Amplitude. Okay, so that's because we have our map range and it's already clamping the value of this guy. So let's say if we have the original value, wiggle value between -1 and 1, we can change it into -10 and 10. So we have something like that. can evolve it using a time frame. Let's see, frame goes into evolution speed. Let's play it back. It's wiggling, so it's kind of like a rubber kind of effects. Amplitude, let's say 5. Actually 1. Yeah, 1. Because it's between -1 and 1, so amplitude needs to be 1. Persistence, I don't get persistent, maybe more crazy noise. If we have high value on the persistence, octave, you can leave it at 2. Node seed. Maybe we actually just want it to be between 1 and 10, like that. Increase the speed, maybe like 10. Okay, that's really cool, right? It's not an effect that's easy to create if you're not using something like animation nodes. I know at the moment it's like, wow, there's like a bunch of nodes there, but in reality it's actually still super basic and super simple. Separate factor. A lot of the nodes is just what I mean is the complexity is not, you don't measure the complexity from the number of the nodes. The color is very faded at the moment because the brightness, maybe we kill that, and we have brightness of 1, saturation, randomize color, randomize between 0 and 1. We have a full color. Yep, very cool, very cool. Let's increase the number of lines just to end this video recording. Maybe we have 50 lines. As usual, because of Blender thing or animation nodes thing, whenever it creates a new objects instance, the material will be set to none or to the default. We're gonna do that, and we have full color working. Very nice, very cool, and you can play it back. So we have something that's more like a what do you call it? Like a musical equalizer visualizations or something. It's a fake one, but it still looks like it. You can do other stuff like maybe rotate the lines or turn it into a circle. Yeah, all sort of things. So hope you like this live noding video recording at BlenderSushi. If you like this video, you can subscribe to this channel, and until next time, thank you.